Okay, in this video, we're just going to remind ourselves of some notation from Calc 3 dealing with projection. So if v and w are vectors in R to the n, then the projection of v onto w is given by projection of v onto w. So the one that's onto is on the bottom. V dot product w divided by w dot product w multiplied by w. And notice that this fraction, a dot product, is always going to be a number. So this fraction is just going to be a number. So remind yourself, or just to remind everyone what this represents graphically. If we have vectors v and w, then the projection of v onto w is going to be parallel to w, and it's going to be basically how much of v is pointed in the direction of w. So it's the component of v that is parallel to w. So this would be your projection of v onto w. It can also be a negative number. The fraction can be a negative number. If we have v and w, then the projection of v onto w would actually be a component in the opposite direction of w. And I guess I should have pointed out that these are right angles. So my projection is opposite of w because we're taking w and multiplying it by a negative number. Okay, so as an example, I want to try and compute the projection of 3, 2 onto 2, negative 1. And then I'll try and draw a picture as well. Okay, so just quickly identifying, this is projected onto this one, so this is playing the role of v and this is playing the role of w in our notation up above. And so we're going to need to know the dot product. V dot product w would be 3, 2 dot product 2, negative 1. Multiply their first components, you get 6. Multiply their last components, you get negative 2. 6 minus 2 would be a 4. If you do w dot product w, we get a 2, negative 1, dot product a 2, negative 1, which is 2 times 2 plus negative 1 times negative 1, which is a 5. And so our formula for the projection of v onto w is v dot w in the numerator, w dot w in the denominator, and then the vector w itself. And we can distribute that constant and make it 8/5 comma negative 4/5. Okay, so that's our answer. Let's draw a quick picture. So let's do 1, 2, 3, 4, 1, 2. Okay, so the vector v is 3, 2. The vector w is 2, negative 1. And if we draw a perpendicular line, it looks pretty close to perpendicular, then our projection would be the component of v along w. And let's see, does this look like it's about 8/5 comma negative 4/5? Horizontally, it's between 1 and 2, so sure, looks a little more like 1.5, but if the algebra says it's 8/5, I'll buy it. And vertically, it's negative 4/5. It's somewhere between 0 and negative 1. So again, I feel like I buy that. Okay, so that's more or less going to be our picture of the projection.